Hello everyone, today we will see overview of OpenFoam directory, which is a fundamental thing for anyone starting with OpenFoam or looking to understand it better. Knowing how the directory are structured or organized is essential for using OpenFoam effectively. So let's get into it. When you first install OpenFoam, as we did last video, you will see these subdirectories inside the OpenFoam directory. So as you see, OpenFoam is organized into several directories. Each one has a specific purpose. And to be able to go to this directory from a terminal, you can do that by change directory command, followed by the variable that holding the path to OpenFoam. And here you see the subdirectories. And the second way, by using an alias. You just write foam and it will take you to the same place. In this video, I'm showing the variable for most of the subdirectories, even if you can navigate to them by alias, as you will not use the variable in the future only in navigating, but for many other purposes. So it's good to get to know them. So now let's see the applications directory. Here you typically find the pre-built applications that come with OpenFoam, and they are mainly split into solvers and utilities. So let's see how we navigate to this one. First way, which is applicable to any subdirectory in OpenFoam, which is by writing the OpenFoam variable followed by the subdirectory name. There is another variable which reflects the path to the application directory in a direct way. Still hard, yeah, I know. So the second way, we will just use alias by writing app and it will take us to the same directory. So let's see what inside. And as expected, we see solvers and utilities. Solvers are considered the algorithms that are used to solve a specific problem in CFD. And in OpenFoam, these solvers are grouped by the types of problems they solve. Let's explore the solvers that used to solve incompressible flow. Here you see simple foam, which is based on the simple algorithm, and piezo foam, which is based on the piezo algorithm, and so on. For instance, say you want to see the source code for a solver, for example, simple foam. You open simplefoam.c, and for a quick information, you can read the description of the solver here. Steady state solver for incompressible, turbulent flow, using simple algorithm, and so on. Okay. The other type of application is utilities, which contains handy tools for things like meshing, pre-processing, and post-processing. And I think this is enough for applications directory, so let's see other directories as well. Next, we have the bin directory. This one is pretty simple. It holds a shell script to make your life easy while using OpenFoam by automating some repeated tasks for you. For example, parafoam, which opens the ParaView software and exports the simulation data to it. Foam clean tutorial, which you will use a lot to clean your case directory from any data generated by utilities, for example, or by any solver. Foam new app. Okay, let's see this one and try it as well. And as you know, you can also go to this directory by many ways. I tried this one here. And now I list the content of the directory, and here you see all the scripts that you can use. And I will try this one here, foam new app. And here you see the script of this command. And you probably will run this command in your OpenFoam directory. I mean the OpenFoam user directory. And this one actually used, for example, if you want to develop a new solver from scratch. So it's a user solver, okay? So, and to be able to go to the user directory, you can do that also by many ways. Here, you can use the normal one, cd followed by a variable, and you can use another way, which I prefer, is by writing alias ufoam, not foam, but ufoam. And as we are developing a new solver, we can follow the same structure as OpenFoam itself. So a solver exists in a solvers directory, and the solvers directory exists inside application directory. So let's do this. And now I run my command here, and I follow the command by the solver name. I will call it my solver. So here we see creating application, which is this line here, and creating subdirectory. And even we can see what's inside to verify. Here is mysolver.c. This is the source file where I should write the application, and the make file, which is responsible for the automation of the compilation process. Okay, now we move to the etc directory. In this directory, you find the configuration files and settings. It handles environment variables, paths, and preferences that determine how OpenFoam behaves in your machine. We go to this directory and see some of these configurations. We go to Foam and then navigate to etc. And here you see all of the configurations file, like bashrc that we have sourced before, control dict, which contains a default setting and the values for our simulation. And now we go to this interesting one, config.sh, which contains some interesting things like aliases. So here, the declaration of the aliases that we were using for a while. So let's try new things like SOL, which will go to the solvers, and UTIL, which takes us to the utilities, and UApp, which taken us to the applications, but in the user directory, our applications. What is the problem here? I think I missed the S letter. Okay, so just let's rename it and copy it to not making any other typo. And here we go. And even we can verify this. And by write U app again. Yeah, and here it's working. And even you can try use sol, which is taking us for the user solvers. Okay. Let's move on and talk about another directory. Platforms. Platforms here is the directory where you find the binary files. For example, binary files for scripts, applications, and library. And actually, we can navigate it. Okay, let's open a terminal and see what's inside this one. Okay. Now we go to platforms and the list, and you will see this folder here, which holds the name itself, holding the compiling information and your machine information. And you go to it, the list, and you will find here the bin and lib. And bin actually where you find the binary file for applications, for example, here. And the lib where you find the binary file for src, which is libraries. Okay. We can go to these libraries and discover this directory as well. So src considered the heart of OpenFoam, actually, like this directory where the source code for libraries exist. Library like finite volume. This library provides all the classes needed for the finite volume discretizations, such as mesh handling, finite volume discretization operators, and even boundary conditions. So also in this directory here include, you will find many important header files like fvcfd.h, which is included in most of applications. And if you navigate back, you will find things like turbulence and transport models. Okay. Let's see what we have covered till now. So, list. We have seen applications, bin, doc. Okay, we haven't seen this. As the name indicates, it's where you find the documentation of OpenFoam. Yeah, that's it. And we have seen etc, platforms, src, tutorials. We haven't seen this. This directory filled with example cases to help you get started with OpenFoam. Like whether you are new to CFD in general or OpenFoam in specific, these tutorials provide sample simulations that teach you how to run cases and understand OpenFoam's setup. And actually, not only this, like this directory include useful starting point for your simulation, for example. But it's also a great way to learn OpenFOAM by working through real-world examples. So, because of that, we will dive deeper into this directory in next videos, especially next one. The last one here is wmake. Okay, wmake directory contains scripts for building or compiling OpenFOAM components. Like, for example, when you compile OpenFOAM from a source or add custom code in your directory, the build process is managed through the files in this directory here. Okay. Thanks for watching. That is a quick overview of the main directories in your OpenFOAM installation. And remember, each directory has a specific purpose, so take some time to explore and get familiar with that.